Now let's have a look at this tool called the spectrum analyzer, which lets you see the frequencies present in each sound. It displays our signal strength versus frequency. So we have the sine wave with the peak here, and this is called the fundamental frequency. This is the first peak from the left, and in case of our pure sine wave tone, it's technically the only peak. So the red one peaks at 440, the next fundamental frequency is 220 Hz, then we have 110 Hz, and the last fundamental frequency is 55 Hz. So you may sometimes wonder why different sound sources generating the same note or the same pitch match, but the sound color is different. This difference is called timbre of the sound, and it lets us recognize different instruments playing even when they play the same pitch or the same note. So for example, a synthesizer playing a pitch of A4 at 440 Hz will match the sound of A4 string on a violin, but you will recognize there are two different instruments of two different sound sources. So timbre is influenced by several factors, but one of the reasons we can tell this difference is because all sound waves that exist in nature contain something called partials, also known as overtones. So let me demonstrate this. The sine wave has no overtones, so let's change the next oscillator to the same pitch of 440 Hz. So now we have two waveforms that run at the same speed and complete 440 cycles per second, as we already know, and we have two fundamental frequencies of 440 Hz. Now I will be using different waveforms, which for now you can think as a different micro instrument of an oscillator. So let's have a look. I will keep the sine wave on, and the second one I'm going to run a saw wave. So what's actually changed here? We still have the fundamental frequency of 440 Hz, but now we actually have overtones from the saw wave, which are the frequency peaks above the fundamental. So this is our fundamental frequency, and these are overtones, also known as partials. And you can also hear this, how the saw wave sounds brighter and much more richer than the pure sine wave. And this is because of its overtones. So now you know the fundamental frequency is the first peak from the left. The frequencies above the fundamental are called partials or overtones. This whole thing is called overtone series, and it's one of the main things that influences the timbre. And timbre is what allows us to differentiate between the sound of different instruments playing the same note or the same pitch.